AP style free response problem 4. Nitrous acid decomposes in soil to produce nitrogen oxide gases and water by this reaction where 2HNO2 aqueous produces NO gas, NO2 gas, and water. The pressure of the container after the reaction begins is shown here. So you can see as time increases, we see the pressure increase until it levels out. So here are the questions we're going to answer in this free response problem. Part A, what is the pressure of each gas at equilibrium? Part B, what is the value of the equilibrium constant Kp for the reaction? Part C, approximately when does this reaction reach equilibrium? And Part D, how would the value of the equilibrium constant calculated in Part B be affected if the container developed a leak during the experiment? Justify your answer. Okay, so in Part A, what is the pressure of each gas at equilibrium? So we have two gases, NO and NO2. Those two gases are the only things responsible for this increase in pressure in the container. The total pressure at equilibrium is 1.6 atmospheres. And it's important to note that that's a combination of the partial pressure of NO gas and the partial pressure of NO2 gas. So now the question is, what is the pressure of each of these gases? Well, we can look at the balanced equation here to help us with that. Stoichiometry indicates that both gases, NO and NO2, will be generated in equal amounts. So each will have the same pressure at equilibrium. At equilibrium, the total pressure indicated by the red line is about 1.6 atmospheres. So each gas will have a pressure of half that, or 0.8 atmospheres. Part B, what is the value of the equilibrium constant Kp for the reaction? So we have to write a Kp expression by substituting the pressures of the two gases. So Kp only includes the gas products, PNO times PO2. In Part A, we found that both gases had partial pressures of 0.8 atmospheres. So 0.8 times 0.8 gives us a Kp of 0.64. All right, in Part C right here, we're asked approximately when does this reaction reach equilibrium? So it happens when the curve levels off, at the beginning of where that leveling off happens. So in this case, it's indicated by the green line, about 11 or 12 seconds. Okay. Part D, how would the value of the equilibrium constant calculated in Part B? Keeping in mind that that equilibrium constant was the product of the two pressures of the two gases. How would the value of that equilibrium constant be affected if the container developed a leak during the experiment? What happens when you have a leak in the container? The container is no longer able to maintain its pressure. So what happens is the pressure of both of these gases decrease. So the ideal gas law predicts that losing moles of gas as it leaks out of the container will reduce the pressure. Since Kp in this case is the product of the two pressures, a decrease in pressure will reduce Kp.